Let's continue on the second statement. According to the second statement, all atoms of an element are identical in terms of mass, size, and properties. Atoms of one element are different from the atoms of other elements. So again, accordingly, we have here carbon atoms. According to the original atomic theory, all atoms of the same element are identical in terms of mass, size, and property. So, for example, these are all carbon atoms. According to Dalton, all these carbon atoms are identical, so they are the same. They have the same size, they have the same mass, and the same properties. So he thought that, again, all of them have the same mass. And after several years, scientists discovered that this is not actually true because an atom of the same element can have different mass. For example, most of the carbon atoms are actually carbon 12, but some carbon atoms have a mass of 13 and some have a mass of 14. So again, these are all carbon atoms, and as you observe here, they are not all identical. They have different masses. We call these types of atoms as isotopes. So isotopes are variants or variation of a particular element which differ in mass. So their only difference is their mass. So let's try to see their number of protons, electrons, and neutrons. Okay, first, and as you see here, this is actually merong 0.011 because this is actually the average of all the isotopes of carbon. We'll discuss more on how we get this average on the next chapter of the book. For now, just remember that this one is not the mass of only carbon 12 atoms. So these are the average of all the isotopes of carbon atoms. And the same for other elements. The mass number in the table of elements is the average of all the masses. So we have carbon. Let's start with carbon 12. Again, it's carbon. All carbon have atomic number 6. In this case, the mass is 12. How many protons are in this atom? We can look on the atomic number 6, and the number of proton is equal to the number of electrons, so we also have 6. And the neutron is mass minus the atomic number or the number of protons. So 12 minus 6, that's equal to 6. Let's go on to carbon 13. Carbon 13, and again, it's still carbon. All carbon have the same atomic number. Protons, electrons, neutrons. The number of proton is 6, and the number of proton is equal to the number of electrons, 6. And then right now, neutron, 13 minus 6, that's equal to 7. And let's go to carbon 14. Carbon 14, atomic number, the same, and the difference lang is the atomic weight or the mass number. Pen, protons, electrons, neutrons. Proton, atomic number 6, equal neutrons. 14 minus 6 is equal to 8. So as you see here, these are the isotopes of carbon. We have carbon 12, carbon 13, then carbon 14. They have the same number of protons, 6, 6, 6, but they have different numbers of neutrons. Carbon 12 has 6 neutrons, carbon 13, 7 neutrons, and carbon 14 has 8 neutrons. Okay, so that's it. So we know that all atoms of an element are not identical in terms of mass. So we call this variation as isotopes. Okay, let's go on to another topic about the ions. So on this picture we have an atom. So this atom have how many protons? 1, 2, 3 protons. How many electrons? 1, 2, 3 electrons, and 1, 2, 3, 4 neutrons. Right now, what is the charge of this atom? So we have 3 protons, it means positive 3, and then 3 electrons, it means negative 3. Positive 3 plus negative 3 is equal to 0. So right now, this atom is neutral. Neutral means walay charge or 0 ang charge. Okay. What if this atom loses an electron? Protons, 1, 2, 3 pa rin. In this case, only 2 are left. And neutrons, 1, 2, 3, 4. Let's identify the charge of this thing. So we have 3 protons, it means positive 3, and 2 electrons, negative 2. What is the charge of this atom? Is this atom still neutral? Obviously no, because there are more protons compared to the number of electrons. So there are more positive charges compared to negative charges. If we add this one, positive 3 plus negative 2 is equal to positive 1. So right now, this is not neutral. This now is a positively charged. And the charge of this one is positive 1. We call this one as an ion. So an ion is yung charge na particle. So there are two types of ions. This can be cation or anion. Cation is the term for positive ion, and anion is the term for negative ion. In this case, this is positive, so we call this one as a cation because it's a positive ion. Okay, here we have the conventional symbol. This is actually lithium because atomic number 3 and the mass of 7. And the charge for this one is 1 plus. In your book, it's actually positive 1. But the common practice is we put the symbol after, the sign after the number. So that's what we will be using on this subject. So we put the sign after the number. Let's go to another atom. Protons 1, 2, 3, 4, 5, 6. Electrons 1, 2, 3, 4, 5, 6. Electrons and neutrons 1, 2, 3, 4, 5, 6. Here we have positive 6 because 6 protons and 6 electrons. So right now this atom is still neutral. So this is still an atom. Let's say this atom receives 2 electrons. Protons is still 6. Electrons, it receives 2. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons, and neutrons the same number, 1, 2, 3, 4, 5, 6 neutrons. So right now we have positive 6 and then negative 8. There are more negative charges compared to the positive charges. So if we add this one, positive 6 plus negative 8, the answer is negative 2. So this becomes a negative ion. So we call this one as a cation because it's negative. And the charge is negative 2. Let's try to answer the last time activity. So we have your element A, B, C, D, E, F, G elements. So we have for the element A, let's identify what element is this. For us to identify the element, just look on the number of proton because the number of protons is equal to the atomic number. So we have 12. So what element have atomic number 12? That's magnesium. And then the atomic number is 12. And the mass is proton plus neutron. That's 12 plus 12. That's 24. And then the charge is what? We have 10 electrons, negative 10. And then 12 protons, positive 12. Negative 10 plus positive 12, that's equal to positive 2. So the charge of this is positive 2. Again, we write the sign after the number. Next, we have element B, atomic number 7. This is a nitrogen atom, atomic number 7. The weight is proton plus neutron, that's equal to 14. The charge is, we have negative 10, then positive 7. Negative 10 plus positive 7, that's equal to negative 3. Next, we have element C, 35 protons, atomic number 35, and that is bromine, Br, atomic number 35. The mass is 80, 35 plus 45. And the charge is, we have negative 36 and positive 35. That's negative 1 charge. Next, we have element D, atomic number 30. What element have atomic number 30? That's zinc. And the mass is 66. And the charge is negative 28 plus positive 30. That's 2 plus. Next is 53. Atomic number 53. What is this element? This is iodine. And then the mass is 53 plus 74. That's 127. And the charge is negative 56 and positive 53. The charge is negative 3. Next, we have atomic number 13. That is the element aluminum. And then the charge is, the weight is 27. And the charge is negative 10, positive 13. That's equal to positive 3. And lastly, we have this one, 37. Atomic number 37. That is rubidium. And the mass is 37 plus 48. That is 15, 85. 85, and then negative 37, positive 37. That's a neutral atom, so we don't need to put any charge here because it's neutral. So here, what elements are neutral? We have rubidium. Next, what are negatively charged? We have nitrogen, bromine, iodine. And then what are positively charged? That's magnesium, zinc, and also aluminum. And you also have this one in your quiz last time. Okay, for your activity for this day, you copy this table and fill up this one. So write the elements here from sodium to krypton, then the atomic number, and then the mass number. Then you identify the number of protons, electrons, and neutrons. So again here, all the elements from sodium up to krypton. So the arrangement is based on the atomic number. And then for part 2, this one, you complete this one. So you identify the number of protons, electrons, neutrons, and then the net charge or the overall charge. And then identify whether it's an atom or an ion. If it's an ion, identify whether the ion is cation or an anion. Again, you answer this activity on a paper, then take a picture of your paper and upload your paper on the Google Drive shared to you last time.